Assalamualaikum and good day. Today, I would like to present my team research titled Developing of Green Concrete by Utilization of Palm Oil Fly Ash POFA. This research has been conducted by myself, Rahim bin Ishaq, Ilham Nasim Muhammad and Abdurrahman Dani.
First thing first, I would like to explain the definition of concrete. Concrete is formed by mix of cement, gravel, sand and water, which desired grade and water similar ratio. Cement is the most material as binder of concrete, which affected their strength. The cement industry consumed a lot of energy and produced a lot of pollution, odor, and noise. Cement manufacturing also contribute of global carbon dioxide emission. Green concrete is described as concrete which contain at least one component made from waste or the manufacturing process doesn't harm the environment or which has high performance and life cycle sustainability. Recycling of waste should be implemented in construction to maintain environmental, economic, and social development.
The increase in the agriculture of rice and palm oil in Malaysia has raised concern about waste disposal that is inappropriate managed accordingly. In developed countries, industrial waste disposal is a huge issue, with some waste being burned in incinerators and the residue dumped on the lands. To protect the environment, industrial waste materials can be transformed into recyclable products. This is the objective of the study. First, to determine the detail of mixed proportion of the concrete's grade 40. Second, to evaluate compressive strength of the green concrete which for POFA to be partially replaced by cement. This is the material we used in the study. First, the ordinary Portland cement OPC complied to BS 12 1996. Then POFA was used to partially replace by cement. After that, cost aggregates of nominal size of range 2.36 mm to 20 mm according to BS 882-1982. And finally, river sand or fine aggregate of nominal size of range 0.15 micrometer to 5 mm comply to BS 882-1992.
This is the mixing proportion was used in this research. Design of normal concrete mix will apply according to the Building Research Establishment BRE guideline. The different molarities of 0 molarities, 8 molarities, 10 molarities, 12 molarities, and 14 molarities of sodium silicate solution were used in this research. Mix of grade 30 of concrete was used. Water similar ratio is 0.45. The ratio of sodium silicate and sodium hydroxide is 1.5.
This is the mixing proportion utilized in this study. Design of normal concrete mix were applied according to the Building Research Establishment BRE guideline. Different percentage of POFA of 0%, 10%, 20%, and 30% were applied. Mixed in grade 40 of the concrete, water similar ratio is 0.46.
This is the method were conducted of this research. The chemical of composition of fly ash was conducted using X-ray fluorescent XRF. Sodium silicate was dissolved using distilled water and left for a day as preparation of the solution before mixing in the concrete. The casting of concrete was done in cube mold measuring 100 mm times 100 mm times 100 mm. A total of 75 cubes concretes were made. Cubes of concrete were demolished after 24 hours, and the specimens were placed in an oven at 70 degrees Celsius for 48 hours and then taken out from the oven and placed in a room at ambient temperature until testing. The specimens of the concrete were tested on compressive strength at 7, 14, 28, 56, and 90 days by using 100 1500 kN Matthes compression testing machine compliant to BS 1881116. The slump test was implemented to evaluate the workability of the fresh concrete according to BS 1881 Part 2 1983.
This is the method were conducted in this research. The British method of concrete mix design for grade 40 was used for the concrete mix design. The specified size of cube concrete mold 150 times 150 times 150 millimeter was used. The casting of concrete was done in cube mold, measuring 150 millimeter times 150 times 150 millimeter. A total of 24 cubes concrete were made. Cubes of the concretes were demolded after 24 hours and the specimens were carefully removed and placed in the curing tank. Then the specimens of the concretes were tested on compressive strength at 7 and 28 days by using a 2000 kilonewton compression testing machine compliant to BS 8811116. This is the detail of mixed proportion of concrete grade 40 per meter cube.
This is the result of semi-log graph of cost aggregate sieve analysis that illustrated. Based on the results show a sample of cost aggregate in all sizes within the limitation and acceptable in mixing of the concrete. This is the result of semi-log graph of fine aggregate sieve analysis that's illustrated. Based on the results show, fine aggregate in all sizes was seen within the limitation and consider appropriate material in the concrete mix.
This is the result of compressive strength. The tables show the compressive strength of concrete has increased with age. The maximum compressive strength, 33.2 Newton per millimeter square, was seen at 10% replacement of OPC by POFA, but still did not achieve target mean strength, that is 53.12 Newton per millimeter square, and lower than control concrete, 42.6 Newton per. Now I'm going to explain the conclusion of this study. In this study, the result of compressive strength was seen lower to the target mean strength. However, is greater than 40 Newton per millimeter square and considered acceptable. Based on this study, the replacement of cement with POFA significantly decreased the strength of the concrete. The POFA replacement of 10% mass of cement achieved the optimum value of the compressive strength and considered the best ratio of cement replacement in a concrete mix at 28 days. Therefore, from this study, the design of mixed proportion of concrete for grade 40 can be potentially utilized as control concrete for further experiment in green concrete study. and eventually the partial replacement of cement by POFA being potential option to reduce environment pollution and can be converted to green concrete as more economical alternative material in construction.